Question 6. Question 6 involves a test for a chi-square analysis. In this question, we are being asked to explore the relationship between two columns of information. In the case of this demonstration, we are being asked to explore if there is any relationship between a gender of a person and the shift that this person is assigned to at work. In order to explore this, we need to use a chi-square analysis in that the two categorical information we have are nominal. That is, gender is a categorical data and shift assignment is also a categorical data. The values in this categorical data are nominal in that by scale of measurement, male and female are categories and they are also nominal type of measurement. Same with shift assignment. This is a nominal measurement because morning shift, afternoon shift, and night shift are two separate entities, and there is no way of measuring which one is of a higher scale than the other. The same goes with male and female. So when you are asked to explore a relationship between two categorical information, a chi-square analysis is one of the methods that we can use to explore such relationship. And we've covered some of the requirements for a chi-square analysis during our lecture time presentation. So let's see how we can use Excel to conduct a chi-square test to explore whether in fact there's a relationship between gender and shift assignment. So question 6 asks you at 5% significance level, conduct a chi-square test to explore whether there is a significant relationship between gender and shift assignment. In order to do this, we need to transform this raw data, these two columns of information which are raw data, we need to transform that into a contingency table as follows. So this is provided for you. I've counted 2 cases for male morning shift. There are 3 cases of male in the afternoon shift and 10 cases of male in the night shift. And for the female, 4 cases in the morning shift, 6 cases in the afternoon shift, and 5 cases in the night shift. These are called observed data because that is what we have observed. This is our sample data and they constitute an observed data. Now, in order to conduct a chi-square analysis, we need to transform this observed frequency count into what is called the expected frequency count. The expected frequency count are the count that we should expect if there shouldn't be any relationship between shift and gender, then this should be the expectation. So we're going to calculate an expected frequency count. It's very important to do this because it will help you to make a decision as to whether the observed is in fact significantly different from the expected. If that is the case, then in fact there's a relationship between gender and shift work. Otherwise, no relationship. So let me show you how we can use Excel to calculate the expected frequency count. To do this, the formula is for each value as observed data, we need to multiply the corresponding row total times the column total divided by the overall total. This is very important. So to do this, in order to transform 2 into an expected count, I'm going to use the formula. The row total for 2 is 6 times the column total for 2 is 15. Then divided by the overall total, which is the total sample size, which is 30. So that is the expected count for male in the morning shift. I'll do that for the afternoon shift. For 3, I'll change 3 into an expected count. To do that, again, the row total for 3 is 9. So 9 times the column total is 15 divided by the overall total, which is the sample size, 30. For 10, the row total is 15. So equals sign row total 15 times the column total, which is also 15, divided by 30, which is the sample size, 7.5. I'll move to the next, female. For the female, 4, to convert the observed data of 4 to an expected value, again, the row total is 6 times the column total, which is 15, divided by the overall, which is the total sample, which is 30. Same for 6. To convert 6 to an expected value, that will be column total 9 times, the row total 9 times the column total, which is 15, divided by the total sample size, which is 30. The last is 5, will be 15. The column total, the row total for 5 is 15 times the column total, which is 15, divided by the total sample, which is 30. So this is the syntax you have to write to have your expected count. So I've done all the expected count for the expected frequency count. Now if you add all this, you should have 15. If you add the female column, it should give you 15. And if you add the total, you should have 6, 9, and 15. So the total here should be exactly as the total we have right here. So that should basically make you have the idea that you are doing it right. If the totals are the same, then it means you've accurately converted this into a right expected count. I mean, if I have to ask Excel to do all this total one time, all I needed to do is to select the values, only the values, and then go to auto sum. If you do the auto sum function, all the total is done. So you notice that the totals here are similar to the totals here, and the total in this segment are also similar to the total in this segment as well. So that is your expected count. So we have the observed count and the expected count. Now we're going to have Excel to analyze the differences if the expected is anything different from the observed, right? And to do this, these are some of few things I would like you to do. Now I noticed that what you've already don't have this portion, which is chi-square critical analysis. It only has the p-value. It doesn't have these two. So just if you can type this in, chi-square critical value and then chi-square test value. If you can enter these two into your sheet, that should be okay, right? We are going to use this function here, which I've highlighted in yellow, to give you some answers right here, and which will enable us to make the decision as to whether to reject or not to reject the null hypothesis. So in order to find a p-value for this relationship, what we need to do is I want you to type in this syntax right here. So it begins with equal sign chi. As you type in, you should notice that there is a drop down which is basically telling you that it's following what you are entering. So test chi-square test into bracket. So when you enter the chi-square test into bracket, it asks you which one are your actual range and then which ones are your expected range. So you have to select your actual range first. These are my actuals. The actuals are the observed. So I'm going to select just the values, excluding the total. Don't include the totals, just the values. And don't also include the column header as well. Just the values, and then bring in the comma sign, and then move to the expected range. And you do the same for the expected range. Don't include the totals, and then close bracket and hit the enter sign, and you should have your results. The p-value. The p-value is 18.88%. That is essentially more than the alpha, right? So the alpha asks for 5% limit. You got 18% in your error. So it means that we need to accept the null, in that the p-value is more than the significant value. Now for the chi-square critical value, if we want to compare the critical value and the test value, then we need to enter the syntax chi-square.inv.rt. So it asks you to define the probability. And for a critical value, our probability is 0.05. So we need 0.05 as our probability. And then degree of freedom is going to be 2, because the formula for finding the degree of freedom for test of independent, which I'll teach you in class, or I may have already taught you, is going to be R1 minus R minus 1 times C minus 1, right? So that should basically be 2. And we'll cover this in class if I haven't done so. So our degree of freedom in this is going to be 2. And then we entered, and we have a critical value of 5.991. Again, the degree of freedom is how many rows and how many columns you have. If you have 2 rows, then it's 2 minus we have three rows, we have three rows here. So we have 1, 2, 3 rows. So that should be 3 minus 1, which is 2. And then times 2 rows minus 1, which will be 1. So it basically is going to be 2 times 1. And then for the test value, to figure out the test value again, we go with equal sign chi-square INV RT. RT, and then the probability here is going to be the p-value, the p-value values that you have. So I'll ask you to basically click on the p-value and then comma and then enter the degree of freedom of 2 and bracket close, and that should get you your critical value. So in this case, we notice that our test value is less than our critical value. So it goes to confirm that we need to accept the null. Anytime the test value is less than the critical value, the null will be accepted. If the test value is more than the critical value, in the case of chi-square, then we reject the null, right? And again, when it comes to the chi-square, the rules are simple. If the test value is less than critical value, accept it. If test value is more than critical value, reject the null. And we could also come to the same conclusion by comparing the p-value with the significant level. If the p-value is more than the significant level, accept the null. When the p-value is less than the significant level, reject the null. So in that case, we've come to the conclusions of the test of hypothesis for chi-square. We therefore have to make a decision here, just because we have is that, first of all, what is the null? The null in this case will be no relationship between gender and shift assignment. The alternative is there is a relationship between gender and shift assignment. So when it comes to chi-square is interested in figuring out relationship. Chi-square test for independent. Look for relationship between two categorical data. So in this case, we're trying to compare gender with shift assignment to explore if there's any significant or statistical relationship between these two categorical values. So since our analysis asks us to reject the null, since the analysis has confirmed that the null should be accepted rather. So in that case, we can say that the null is valid and the alternative is not. So we're going to say that the decision will be that the null is valid statement, hence there is no relationship between gender and shift assignment. The reason being so because the test value is less than the critical value. also the p-value is more than the significant value. All right. So this is basically conclude our analysis, just to give you an insight into how a chi-square can be used to explore whether there is any significant relationship between two categorical information. Now again, the important part here is that where sometimes students get issue with that has to do with how to calculate the expected. It is always going to be the row. Expected is the row total times the column total divided by the sample size, right? Divided by the sample size. This should give you the expected. And for the degree of freedom, as I mentioned, is given as the number of rows minus 1 times the number of columns minus 1. And that should give you your degree of freedom. And when we did that, what we had was we have 3 rows times 2 columns. And this should give you, this is equals to 2. So that explains why our degree of freedom happens to be 2, and we use that in calculating for the chi-square critical value and chi-square test values. And that's it.